Good day, everyone. Today, we will study arithmetic and geometric series. In our previous lesson, we learned how to identify arithmetic and geometric sequences and how to find their nth terms. Today, we will go one step further by finding the sum of the terms in these sequences. By the end of the lesson, you will be able to distinguish a sequence from a series and solve problems involving arithmetic and geometric series. Imagine that Maria saves money every week. She saves 100 pesos during the first week, 120 pesos during the second week, 140 pesos during the third week, and 160 pesos during the fourth week. Suppose she continues following this pattern. Can you determine how much money she will have saved after 10 weeks? Finding the total by adding every amount one by one is possible, but it becomes time-consuming when there are many terms. Today, we will learn formulas that allow us to find the total quickly and accurately. At the end of today's lesson, you should be able to differentiate sequences from series, illustrate arithmetic series, illustrate geometric series, and solve problems involving arithmetic and geometric series. Please keep these objectives in mind because they will guide our learning today. Before discussing series, let us first recall what a sequence is. A sequence is an ordered list of numbers that follows a pattern. For example, 2, 5, 8, 11, 14, and so on. Notice that these numbers are simply listed in order. Now consider this expression. 2 plus 5 plus 8 plus 11 plus 14. Instead of listing the numbers, we are adding them together. This is called a series. Remember this simple idea. A sequence is a list. A series is a sum. That is the main difference between the two. An arithmetic series is simply the sum of the terms of an arithmetic sequence. For example, if our sequence is 5, 8, 11, and 14, then the corresponding arithmetic series is 5 plus 8 plus 11 plus 14, which equals 38. Instead of adding many terms one by one, we use a formula. The arithmetic series formula is Sn equals n over 2 times the quantity I1 plus In, where Sn is the sum of the first n terms, I1 is the first term, In is the last term, and n is the number of terms. Let us apply the formula. We are asked to find the sum of the first 20 terms of the sequence. 4, 7, 10, 13, and so on. First, identify the given values. The first term is 4. The common difference is 3. The number of terms is 20. Since the formula requires the last term, we first compute the 20th term using the arithmetic sequence formula. After obtaining the 20th term, we substitute the values into the arithmetic series formula. The sum of the first 20 terms is 650. Notice that in the previous example, we first had to find In, or the last term, before we could compute the sum. Sometimes, we can avoid that extra step. Recall that In equals I1 plus the quantity n minus 1 times d. By substituting this expression into the arithmetic series formula, we obtain another formula. Sn equals n over 2 times the quantity 2I1 plus the quantity n minus 1 times d. This is called the shortcut formula because it allows us to compute the sum directly without first finding the last term. Instead of finding In separately, we substitute the values of I1, d, and n directly into the formula. This saves time while giving us the same correct answer. Let us solve the same problem using the shortcut formula. The first term is 4. The common difference is 3. The number of terms is 20. We substitute these values directly into the formula. After simplifying, we obtain the same answer. 650. Notice that both formulas produce exactly the same result. The shortcut simply requires fewer steps. Now let us move to geometric series. A geometric series is the sum of the terms of a geometric sequence. For example, 2 plus 6 plus 18 plus 54. Instead of adding each term one at a time, we use a formula to find the sum more efficiently. The geometric series formula is Sn equals I1 times the quantity ar raised to the power of n minus 1, all over ar minus 1. Where Sn is the sum of the first n terms, I1 is the first term. Ar is the common ratio. N is the number of terms. This formula allows us to find the sum of a geometric series quickly, especially when the series contains many terms. Let us solve an example. We need to find the sum of the first 6 terms of the sequence 3, 6, 12, 24, and so on. Identify the given values. The first term is 3. The common ratio is 2. The number of terms is 6. Substitute these values into the formula. After simplifying, the sum of the first 6 terms is 189. Today we learned that a sequence is an ordered list of numbers, while a series is the sum of those numbers. We also learned the formulas for arithmetic and geometric series and applied them to solve problems efficiently. Instead of adding many terms individually, these formulas help us obtain the total quickly and accurately. Before we end today's lesson, think about this question. Why is knowing the total important? Where can we apply this in real life? We can use these ideas when computing total savings, total salary, total expenses, total sales, or total investments. Understanding series allows us to make better financial decisions and more accurate predictions. That concludes our lesson for today. Thank you for your active participation. Please review today's formulas and continue practicing so that solving series problems becomes easier. Have a great day, everyone.